The events of the past couple of years illustrate the fact that even with the government restrictions in place, it is a difficult balancing act for a bank to earn a profit while maintaining sufficient liquidity to handle those periods of lows that naturally occur in the business cycle. When a bank is not able to maintain proper liquidity, its alternative is an overnight bank loan influenced by the Fed's fund rate. Our banking system is such that multiple deposits generate an expansion of money. As the checks of one bank are deposited into another, the illusion of new money exists and leads to even more new money being created. This table illustrates the creation of new money based on a single $100 deposit made into one bank. Each subsequent bank can lend a smaller portion of $100 after factoring in the reserve requirement, but overall total deposits in all banks will increase. If you look at Bank A, you see that a person deposited $100 into Bank A. The required reserves for this banking system is 20%. So the required portion that Bank A must set aside for reserves is $20. And that leaves them with excess reserves of $80, 100 minus 20 being 80. Those $80 can be loaned out and are in essence new money being created. So let's say we loan out $80 to Bob. Bob then goes to his bank, Bank B, and deposits his $80. The Bank B can treat it the same way. They only need to hold $16 aside. That's their 20% reserve ratio. That leaves them with excess reserves of $64, which they can then in turn loan to Larry. Larry deposits into Bank C. 20% of his $64 is $12.80, so Bank C can loan out $51 and $20 to Joe. This process continues. This shows that in total the original $100 deposit will end up adding $400 into new money in our system. This is based on a reserve ratio of 0.2 or 20%. The money multiplier is a key measure in banking that helps to predict the money supply that will be available to drive economic growth. As you can see from the formula, if the reserve requirement is 20%, the money multiplier will be 1 divided by 0.2, which would be 5. We can use the money multiplier multiplied by the excess reserves to determine the maximum checkable deposit creation that will be provided by the new money entering the system. The maximum amount of new money created by a single dollar of excess reserves is the definition of money multiplier. The higher the required reserve rate, or R, the lower the multiplier would be. So if a bank's required to hold a bigger portion of the money aside in reserves, there's less money they can in turn lend out. So the money multiplier is smaller. It would be smaller. There's also a reversibility to the money multiplier effect. Making loans creates money, but loaned repayment destroys money. Ironically, one of the things that is slowing the current economic growth is people paying down credit card balances and other loans. This is, in effect, removing money from the system. By using leverage, a bank can use borrowed money to invest, which leads to greater profits for investors if things go well, but increased losses if things go bad. The government in the past has stepped in to bail out banks who have made bad investment decisions, leading to a moral hazard. If banks do not have to assume the risk of bad decisions, there's no incentive for them to make more conservative decisions in the future. Bankers have lobbied the government against any attempt to require lower leverage levels, so that the current regulatory system relies on bank supervisors who attempt to prevent the banks from making bad loans. That system was unable to prevent the recent financial crisis. Here's a self-check. When a commercial bank makes loans, it creates money, and when loans are repaid, money is destroyed. Explain. Well, when a bank makes a loan, it also creates a checkable deposit of equal value, and this increase in checkable deposits results in an increase to M1, or money. When we apply this logic to fractional reserve banking, the expansion of money supply is compounded, and, as we know, the reverse logic applies when loans are paid off. The individual writes a check to pay off the loan, which reduces the amount of checkable deposits within that bank. Here's a problem for you. A commercial bank has $100 million in checkable deposit liabilities and $12 million in actual reserves. The required reserve ratio is 10%. How big are the bank's excess reserves? Our required reserves are $10 million, 10% of $100 million. So our excess reserves would be $12 million, which is what we actually have, minus the $10 million that we're required to have. So we would have $10 million in excess reserves. Remember, those excess reserves are usually loaned out.